Okay, so we're going to look at electron configurations again. This time we're going to include the topic of valence electrons and electron configurations for ions, okay? So I'm going to go ahead and share my screen. Share. All right. There we go. Okay. All right. So let's look at the topic of valence electrons, okay? And what are valence electrons? They are electrons that are most responsible for an element's chemical / physical properties, right? And secondly, they are the electrons, on the outermost energy level, okay? All right, so they're the electrons that are on the outer energy level. All right, those are your valence electrons. So let's draw the electron configuration for sodium, all right? And what we'll see is we've got 1s2, 2s2, 2p6, 3s1. All right, that's cool. Well, if I identify my highest energy level, that would be the third, right? So the highest energy level equals third. And according to my configuration, I have one electron on the highest energy level, right? Therefore, I have one valence electron. Simple as that. All right. Let's look at another example. This time, let's do phosphorus. All right. Phosphorus is atomic number 15. All right. So we'll go 1s2, 2s2, 2p6, 3s2, 3p3. Okay, well, let's identify our highest energy level. That is the third, right? I've got 2 electrons in s orbitals on the third energy level, and I have 3 electrons in p orbitals on the third energy level. So my highest energy level is the third. The number of electrons on the highest energy level equals 3 plus 2 equals 5. Therefore, I have 5 valence electrons. There you go. Okay, let's look at another example. Let's do iron. It's number 26. Okay, so I'm going to go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 1, 2, 3, 6. All right. Now, this time, my highest energy level is the fourth, right? Because 4 is bigger than 3. There are 2 electrons on the fourth. Therefore, there are 2 valence electrons. right? Another thing we should probably write about our valence electrons up here are they are the electrons that participate in bonding. So we'll see that this is important, right? They are either transferred, given, taken, or shared. So we'll talk a lot about valence electrons. Okay, right now we're just looking at how to identify how many valence electrons we have based on an element's location. I mean, based on an element's period electron configuration. And you see that it's pretty easy, right? We could do one more. Let's see, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. Okay, well this time, oops, don't want an eraser. Let's undo that. This time I see that the highest energy level is my fourth. There's also a fourth right here. So the highest energy level equals fourth. And there are 7 electrons on the highest energy level, right? Therefore, it's my 3 dots, therefore, this element has 7 valence electrons, okay? This element here, I didn't tell you, that would be 1, 2, 3, 4. This would be bromine, all right? Now, let's take this a step further, all right? Let's look at our periodic table, okay? And I'm actually going to go over like this. I'm going to go to all of my notes, and I'm going to pull up a blank periodic table, or let's just pull up this periodic table here. Okay, well, let's look at how cool this is, all right? Let me move my picture here. Now, I'm going to do several things. Let's look at hydrogen. 1s1. Lithium. 1s2, 2s1. Sodium. 1s2, 2s2, 2p6, 3s1. Let's go ahead and do one more. Potassium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Now let's stop right there. What I want you to notice is the choice of my elements: hydrogen, lithium, sodium, potassium. And let's look at that at the periodic table. Hydrogen, lithium, sodium, potassium. Okay? Now, let's go back to this. This guy has 1 valence on the, on the first energy level, right? Lithium has 1 valence on the second energy level, right? Sodium has 1 valence on the third energy level, all right? And then potassium has 1 valence on the fourth energy level, all right? And it just so happens that they are all reside in group 1, okay? Groups are vertical and periods are horizontal, all right? You need to know that. Horizontal, rows, and groups are vertical columns. Okay? So everyone that we just wrote a configuration for is in group 1. And they all had 1 valence electron. If I was to do the same thing for my group 2 elements, they would all have 2 valence electrons, right? I'm going to clean this up. So what we just said was everybody here has 1 valence electron. Everybody here has 2 valence electrons. Well, if I was to, I'm going to skip over these, all right? And I'm going to look at just my S and my P block elements. Recall that. And my S and P block elements are called my representative elements. Okay, there's a lot of trends represented in these 2 groups. Okay, so I'm going to go like this, S, P. All right. I'm going to look at the numbering system. I want you to realize right here that it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I can also, that's actually the numbering system for B, right? I could also, let me clean this up, number this 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. What that means is I did not count these groups. I only counted the S and P block elements because those are my representative elements, right? So I just counted these element groups and I just counted these element groups. And when I do that, I count from 1 over to 8. And when I count my groups in such a way by omitting the D block, right? I just don't include these groups. And when I count them 1, 2, 3, 4, 5, 6, 7, 8, what I see is real important. I see that the group number 1 through 8 for representative elements is equal to the number of valence electrons of that element. Okay, there's an exception here. There's always an exception. Exception equals helium. Helium only has 2 valence electrons. Okay, and let's look at the periodic table and see that helium is right here, right? Let me clean this up a little bit. Oops, let's clean it up like this. All right, helium lives right here. We would expect him to have 8 valence electrons, but he only has 2 valence. Notice he's only got 2 electrons, but his outer shell is filled up. That 1s is filled up with 2, okay? So another thing I need you to notice is that hydrogen lives in what period? He lives in period 1. Lithium lives in period 2. Sodium, period 3. Potassium, period 4. We also did bromine over here. All right. I think we also did iron. Now, where hydrogen, you please try with me, okay? I know this is hard on your own, but you're not on your own. I'm teaching you. Hydrogen is in group 1, right? Because hydrogen is in group 1, I know that he's got 1 valence electron. Hydrogen is in period 1. Therefore, I know that his valence electron is on the first energy level. Let's look here. Hydrogen has 1 valence on the first energy level. Well, lithium is in group 1, so he has 1 valence, but his valence is located on the second energy level. Sodium is in group 1, so he has 1 valence, and it's on the third energy level. Potassium is in group 1, so he has 1 valence, and it's on the fourth energy level. Let's go over here to bromine. Bromine has 7 valence, and they're located on the fourth energy level. So what we just determined was that the group number of a representative element is equal to the number of valence electrons. And the period number of a no, I don't even need to write a representative element. The period number is equal to the location of the valence electrons. It also equals the number of energy levels. Okay, so I could say which element has 5 valence on the fourth energy level, right? And this becomes easy. If I have 5 valence electrons equals group 5 of representative elements. Okay. And if they are located on the fourth energy level, then I'm located in period 4. So let's find the element. Let's clean up our periodic table. So I'm looking for the element that has 5 valence, and those 5 valence are located on the fourth energy level. Well, I know everyone here has 1 valence electron, 2 valence, 3 valence, 4 valence, 5 valence, 6 valence, 7 valence, and 8 valence, with the exception of helium. So I know that one of my element is in here, right? Because those are the elements with 5 valence electrons. Well, his are located on the first, second, third, fourth. So arsenic has 5 valence electrons on the fourth energy level. Okay. What about iodine? Iodine has 7 valence on the fifth energy level. And what about barium? Barium has 2 valence on the 6th energy level. So that's how electrons and the electron configurations in the periodic table go together. The periodic table is like a huge graphic organizer, right? It's really pretty cool. And that's what we're getting into, and we'll talk about for the next week or so. Okay, I need you to develop your questions for me and bring those to class. All right? Okay. Okay. I'm going to stop this there. I was planning on doing ions, but I'm just going to make that a whole different video. Okay, so I'm going to stop and end.